Welcome everyone to our webinar on how hydropower can play a role in our net zero carbon future. I'm Amy Volkins. I'm a strategic account executive for climate work at RTI International. And for our discussion today, we'll spend about 45 minutes with this esteemed panel talking about some foundational questions related to hydropower. And then, as Cameron said, we'll open it up at the end to questions from the audience for the last 15 minutes. So I'm really pleased to be able to introduce our panelists, each of whom has a particular area of expertise related to hydropower. So first up, we have Sean Carney, who is a senior water resources engineer for RTI Center for Water Resources. Sean is an expert in operational decision support systems, flood risk hazard analysis, hydrologic forecasting, and climate change analysis. Sean leads many of RTI's hydropower projects. For example, he works with DOE and the national labs on methods to evaluate the trade-offs between energy demand supplied by hydropower and the environmental and ecological impacts under a shifting climate. Sean also leads RTI's work with the Tennessee Valley Authority on their operational forecasting system and is currently evaluating the benefits and impacts of a new pumped storage hydro facility. Sean received a master's degree in civil engineering from Colorado State University, and you are going to hear that all of us are located in Colorado at the minute. Our next panelist is Shanna Durham, who is a senior mechanical engineer with the U.S. Bureau of Reclamation's Technical Services Center. She is an expert on turbine design, manufacturing, and testing. Shanna leads multiple projects that evaluate how low reservoir levels impact hydropower generation and how to overhaul and optimize hydropower units. Shanna holds a master's degree in mechanical engineering from the University of Colorado. Our final panelist is Greg Stark, who was a technical lead for the hydropower program at the National Renewable Energy Laboratory. Greg is an expert on hydropower and pumped storage hydropower projects, and particularly how to combine systems engineering with financial and economic perspectives. Greg's work focuses on the optimization of energy use across multi-domain systems and the integration of new generation into existing electrical grids. Greg holds a bachelor's degree in chemical engineering and dual master's degrees in control systems and management from Purdue University. So thank you all so much for being here today for this discussion. Okay, I'm going to hop into our foundational questions. The first one goes to Greg. And the question is, the phrase renewable energy is often associated with solar and wind energy. How does hydropower complement these other renewable energy sources?
Okay, well, thanks, Amy. Yeah, the two most common areas you think about as far as it being complementary is first in firming, or kind of its dispatchability. It's able to kind of back up renewables, how they vary from time to time. That's one key thing about it. And then the second is its firm capacity, and that hydro is something that you can count on being there, whereas with other forms of renewables, it's highly weather dependent. Would kind of be the two key areas that I see.
And then the way that, oh, go ahead, Sean. I was just going to say the way that we'll work is we'll open it up to Shanna and Sean in case they want to add anything to Greg's comments.
Yeah, I just say, the one other piece that we talk about a lot is just the difference between like conventional hydropower, which is thinking about like dams that are on river systems, like the Grand Coulee Dam, and others that are on major river systems that have a big impoundment behind them, and they're generating hydropower. But then pumped storage hydro is another form that's used a lot, where you have a higher reservoir and a lower reservoir. Sometimes they're off channel reservoirs, or they could be on channel, but off channel reservoirs as well. And in those cases, it acts more as a large battery, where you pump water uphill when energy is cheap, or where there's a plethora of energy on the system, and then you generate when you really need it. So when the wind and solar is not available.
Yeah, very much agreed. The other thing that I'll just mention, and it's kind of complementary in another way. When you think of most forms of renewables, kind of variable renewables, they're use it or lose it type technologies. The wind, you can't capture it at that particular moment. If you don't use it, that energy is lost forever. The same with solar. Whereas in hydro, even the run-of-river plants often will have like 4 to 6 hours of storage. And so it allows you to capture that energy, as it goes by, and then use it later. And that can be really handy for filling in lulls that you see in wind and solar, especially in those areas of the country that are moving to very high renewables. Most of the country, it's not a big deal yet because there's still gas or other things on the system to back up variable renewables when they do have lulls. But as you get closer and closer to that 100%, it becomes really important to have that ability to have that stored energy.
That's a great point.
Oh,
Shanna.
and just for the audience, if you notice, Sean and I keep glancing off to the sides. We're sitting in the same room, so we're kind of talking to each other at the same time as we're talking to you guys.
Yeah, so Greg and Sean said it that our reservoirs are our bank of batteries, basically, and we can utilize that storage or that water when needed, and can come on very quickly. We can be at very low output or speed no load, and then ramp up to full capacity within 20-30 seconds, depending on some of our power plants. So we can come online very, very quickly and get those peak demands if needed, which is a great a thing that hydro does for us.
So Shanna, I'm going to stick with you. I want to give each of our panelists an opportunity to respond to the next question, but Shanna will go first. So what do you want this audience to know about the current state of hydropower, as well as the priorities of your organization that you're representing today?
So I work for the Bureau of Reclamation, and we have projects that are located in the 17 Western states. And our mission is to manage, develop, protect water and related resources in an environmentally and economical sound manner for the interest of the American public. But with that, an added benefit is really clean, flexible, and high efficient power generation. And we at Reclamation, we are the second largest producer of hydroelectric power in the United States, just behind the Corps of Engineers. And we have 53 power plants that annually provide more than 40 billion kilowatt hours. So that's about enough power to serve 3.5 million homes. And our goals, not only for delivering water to the West, but is to improve flexibility, increase efficiency, and increase our capability of our existing facilities. And so by doing that, we are improving and optimizing our existing generation systems. We're trying to generate more power for the same amount of water that we need to deliver downstream. And as everyone knows, our climate is changing. And with that, our organization is pulling all of our resources together, and we're trying to strengthen our basin systems and maintain our water delivery systems.
Thank you so much. And Sean, could you go next?
Yeah, I'd say just, the main thing here, this is really an exciting time, I think, for the hydropower industry as a whole, but it's also a really challenging time. There's some pretty big shifts happening now within the industry, obviously, as there's all this discussion about moving to net zero carbon emissions and how we get there. And so hydropower plays a big role in that. And that's really changing the way hydropower is being used. And, Shannon, you've talked about this just when you're kind of getting ready for all this about how that's changing within the reclamation from, I think you said, like just just running constant versus having, following the signal and that, demand and that. So it's a really exciting time, but it's also challenging, just, as you mentioned, just the potential uncertainty about what the future is going to bring in terms of the climate. And so, I think within our RTI, just talking about like why are we interested in this? I think within RTI we have some unique perspective, and just we have people that span a bunch of different disciplines, from economics and energy research and electric vehicle adoption and economic development and carbon capture. But then, like within the Center for Water Resources, which I'm a part of, do a lot of work with water management, and so we like to say we kind of sit between the research and actual application, and we've done a lot of work with different groups on the water management side. And so I think, thinking about what does that bring for the hydropower industry, or what does the hydropower industry, where do we see potential? And one thing we've recognized is just the benefits for improving like the management systems for kind of the water management, but that as part of that is the hydropower, and just the potential to eke more out of the hydropower, or with the same amount of resources within the constraints that are available or that are on the system. How do we make best benefit of the resources that are available? And part of that could be improvements to forecast information, and the whole idea of forecast informed reservoir operations, and using that to help with anticipating what's coming and being able to operate to maximize that hydropower that's available. So it's kind of our perspective.
Thanks, Sean, for the different lenses of energy, water, and climate, and the complexities. I'm going to ask Greg, our holistic systems expert, to make some remarks on behalf of NREL and his interests as well.
Sure. Yeah. I don't know if people realize it, but each of the national labs kind of have their niche that they work in. And one that NREL has had for years is grid integration, how you bring new stuff onto the grid. And so we've been working in that space as far as bringing wind and solar onto the grid for years. But we were doing that from the perspective of things just happening naturally, as far as business as usual, whatever made sense in terms of pricing. Well, recently, in the last few years, there's been a really big push to going to net zero. People, every day you see it in the news. And what we found with that is, to get there in our modeling work, we had to do a much better job of representing hydro. Because in the past, you could get away with not having great models for hydro, and you didn't worry too much about it because there were other things that could kick in. Whereas when you go to net zero, hydro becomes a key player in terms of, it's about the only thing left on the grid that's dispatchable. And so you want to make, it's a really important resource. And so you want to make best use of that. And that's how we came to know RTI, because we're working with them on integrating river basin operations models into our grid models. And so a really important area for us is to make best use of existing assets, and in particular, the hydropower system throughout the US. The other area where we do a lot of focus on is on the pump storage side of the house. Because when we look at projections to get to a low carbon system, whether you're looking at the administration's goals, which they're hoping to get there by 2035, others are looking at a 2050 timeframe. We see a lot of build out of storage, and especially longer duration storage. And so we want to make sure whatever storage is built out is the right kind of storage. And so we did a life cycle analysis as far as carbon impact on pump storage hydro, and we focused on that area as well. And then resource availability, where is it practical to build pump storage? And then the other area that we're focusing on as an organization is the workforce to support all this. Because when you see a huge growth of something like pump storage hydropower, people don't stop and think about, it's been quite a while since we've built facilities of that size, and do we have the skills and just the work crews to get that work done? And so that's a recent focus of my organization, is kind of to bring better understand what's going to be needed in that area, because we're seeing organizations that are talking about building pump storage hydro over the next 5 to 10 years, and yet there are concerns as far as how will they get it done.
Thanks, Greg. I see some questions rolling in. One is about new hydropower and one is about the trends in existing hydropower. So I'll try to weave these in because they correlate really nicely with our next couple of questions. So our next question is, sometimes the discussion around renewable energy focuses on building new assets. What are some of the challenges bringing pumped storage hydropower plants online, and how can recent federal incentives help alleviate these challenges? And Sean, I'll open it up to you first.
All right. Well, I mean, I think Greg just hit on it. It sounds like you guys are also talking to people about how to bring on new hydropower or new pump storage. And I'd be really curious kind of what you're seeing on with other groups also. But, we've been doing some work with Tennessee Valley Authority. And, the first thing I think is just they really recognize the benefit of pump storage. And they have an existing facility in Raccoon Mountain, which talking to the operators, that's like an invaluable resource for them just to help with just balancing the needs with the grid as it is right now, let alone looking ahead to some of the challenges that Greg was talking about there. And in talking through stuff with them, they're actually in the process. They just announced a couple weeks ago that they're entering into the NEPA process to really evaluate a couple. There are 3 different sites that they're looking at. One is just expanding Raccoon Mountain, and then 2 other locations. And just in some discussions related to our project, we were just asking, like what is it that's really driving this? And they raised 3 different points. One is, and I'll get to the question here in a second, but I think it's just important. Like they see like the wind and solar, which is always the thing. Okay, we're balancing the wind and solar, but they also have a large nuclear fleet there, and that's really important. But like nuclear is like the other end of the spectrum, where with wind and solar, those come on and off, and you need something to balance that. But then with nuclear, it's always on, and there really isn't the ability to flex that in terms of how much, and it's really valuable to leave it on. And so the pump storage really is beneficial from both balancing the wind and solar as well as the nuclear. And then the third strategy they're looking at for dealing with carbon emissions is carbon capture. And just on that side, leaving that on, because of the large investment, they see the need for that variable ability that pump storage brings. And so kind of go into what are the challenges. Just the capital investment when you're talking about these massive projects, it's $1 billion that they're considering, and like that is, it's not something that you get an immediate return on. You're investing in something that's going to be in place for 30, 50 years. Like the Raccoon Mountain, they constructed in 1978, and it still is running strong. They have no plans of stopping it. So that's something that there's continued return on the investment, but it's not an immediate return. And so that's a real challenge, and just getting investors that are able to, and finding the financial structures that work for that. Then just the environmental impacts of like changing river flows and that. And so like off channel or closed loop systems are those have less of the environmental impacts, but that's a real challenge there. So just on the federal incentives, there's with the Inflation Reduction Act, there's a investment tax credit that they announced that just changed I forget the name of it, but change it to a technology neutral approach where they'll give a 30% tax credit with there's certain qualifications in that, but generally a 30% tax credit for new storage, and so pump storage falls under that. So that's just a big opportunity for developers who have been on the cusp of able to move forward. That there are a number of plants that are, from what I understand, have been on the cusp that are going to be announcing moving forward with that. And so that's 30% plus some additional depending on other pieces. So just talking to TVA about just how likely they are to actually move forward with this, and I think a real insightful comment was it really depends how serious our country is about this transition to net zero. And if we take it seriously, and Greg, I think you talked about this, just that that there's a point where it's absolutely necessary when you get to really high renewable amounts, the amount of storage that's requires something like these massive facilities like Raccoon Mountain. And so it's really, how serious is our country going to be, as well as TVA to follow through on some of these goals. And they feel like they're going to be moving forward. At this point, they're just in the NEPA phase. There's a lot of steps before they're digging all that, but they are really investigating this seriously. So I don't know if Shannon, Greg, if you had any thoughts on that as well.
I have thoughts on it, but Shannon, do you want to jump in, or?
No, I completely agree.
Okay. Yeah, a couple on some, and we're doing some research in this area right now. We're working closely with Argonne National Lab on PSH commercialization, some of the challenges there. And Sean mentioned it up front, just the upfront capital cost, but there are things that people don't stop and think about. One of the groups that we interviewed talked about they could figure out how to finance it. They thought, and dollar-wise, the money worked, but the investment was so large that investors were worried about the opportunity cost to it. And what I mean by that is they would have spent so much money on that one project that it would have been difficult for them to maintain their other assets in their fleet. And so figuring out how to deal with that, and this was a mid-sized utility. And so there's some challenges, whereas for somebody like a TVA that's bigger, that becomes easier. They have more diversification and ways of being able to handle things like that. But that's one challenge. If you only
have a couple of facilities,
if you only have a couple of facilities, and yet you see high value in pump storage hydro, how do you move forward with that?
Without just completely neglecting the one.
And then the other theme that we hear coming up time and time again is we've probably talked about 36 different stakeholders in this area, has to do with market uncertainty. Just the challenges from when you come up with the idea to when you're actually finally seeing revenue. And we're doing some research in this area, working with a few firms, really trying to have the timeline on being able to bring storage online. And so that will help with that a lot. But there's a lot of concern from investors on that point, on the financial, there's financial and policy uncertainty. They're not even sure what the markets are changing so quickly on the grid. What's it going to look like 10 years from now?
How much is like the regulatory environment? And I know that like NHA, the National Hydropower Association, they've really pushed to try to speed up that whole licensing process. Is that a major concern as well, or is that?
That is a concern. We have we've done work in that area as well. And with the closed loop pump storage, they've shortened the timeline on it down to, I think it's 2 years now, but getting the equipment to match that timeline, there's still some issues there. But there's work being done on one of the firms that we're working with. They're thinking that they can cut construction timelines by at least a third and maybe half. And so there's some promise there. But the other thing that I wanted to mention in uncertainty, this is a theme that's been coming up, is just technology uncertainty. People will look at it and they think, wow, this is a good technology, but they know that the goal's a little ways out, and they're concerned that, whether it's next week or 10 years or 15 years from now, somebody else will come up with something else. And so figuring out ways to address that. And so if we can shorten the timeline, that really helps to do that, because then they start seeing revenue right away.
That makes sense.
So those are kind of a couple of areas that I've seen.
Thanks, Greg. I'd like to combine a couple of questions from the audience and get Shanna's thoughts. We're getting a couple of questions about the graph that was on the previous slide and the fact that few hydropower installations have been built recently. And so could you speak to, I'm combining some questions, so forgive me, but we have one question that says very few hydropower installations in the last 40 years. Is that because the highest opportunity sites have already been developed, or is there large capacity for new installations at new sites?
Yeah, great question. So this graph is really nice to show us how hydropower really starting in the 1900s and then really ramping up, peaking out about 1960s in the United States. And so new power generation then, or new new power plant fabric buildings and all that has really dropped off. And you know, I think a majority of it was because, yes, we've gotten the big reservoirs, right? We've tapped into the big locations. But at Beer Reclamation, you know, we only have 53 power plants, but we have over 400 dams. So there's a lot of dams that don't have power plants that could be utilized. And I think I'll be talking about that more in the next question. But and then why we dropped off, I'm not sure if Sean or Greg know, but you know, it could
Maybe
be
I
more,
can jump in there if that's okay.
yeah,
Sure.
regulations or difficulty building and cost. And
Sure. There, I'm just looking at my co-panelists, and I'm the only guy here old enough to realize, and I would ask you if we were in a normal setting where there were an audience and you could see them, to raise your hands if you remember the first time that we were going to go all electrification in the US. See, and people don't know that are younger. When I was a kid, nuclear was going to be the path forward. And so the reason you see the huge build out of pump storage in that time frame was to pair nicely with nuclear, because nuclear is not real friendly to turning down at night. And so at night, your loads would drop off. You need something to do with that energy. So you would send it over to your pump storage plant. You'd pump the water uphill. And then the next day, when there, you know, the air conditioning loads or whatever, you needed that energy, then the pump storage could provide that. And I remember as a kid, our science class, we'd go up to Lawrence Berkeley Labs and they would talk about all electric, how that was the future of the US. It didn't pan out with nuclear, but that's why you see that huge bump in the big build out in kind of the 60s and 70s. Why you're seeing people talk about it again today. And, you know, I mentioned NREL does a lot of grid integration model. And when we look on a national scale, kind of the tipping point for needing storage longer than about 8 hours, kind of you start hitting the 8 to 10 hour time frame, is when variable generation, you start getting above 80% energy for that. And that pump storage starts to come into its own. And as of right now, in those time scales, when you get pretty much everywhere 10 hours and longer, but even in some areas 8 hours and longer, pump storage can be more cost effective than other forms of storage. And so that's kind of why the renewed interest in it. But it's, you know, just that gap between going all electric with nuclear, that not working out, and then there's this phase where we're not up to those levels of renewables yet. That's why there's the gap there.
Thank you. And that really interesting history too. So our next question, and Shanna, I'll kick it off to you first. We know we can use our existing hydropower assets more effectively. What are the strategies we have available to produce more power with existing assets?
so, yes, this is a multi-stage question. So we, of course, like I spoke about, had 53 power plants, and originally our capacity was 13.5 gigawatts. And over the last decades, like I just saw that chart that we had building up all of those power plants, and then we're slowing down. But normally you need to overhaul overhaul a unit and return it to like new condition about 40 to 60 years after first turning it on. I mean, of course, there's maintenance, and so when we're doing those overhauls, we are looking at how we can optimize and get more power out with the existing framework of the generator system. So we are looking at upgrading and increasing generator capacity of our existing facilities. And to this date, we've increased by 2.2 gigawatts from our original installation. And so that's a large amount just with our facilities. And then
Shannon,
go ahead.
How much of that is like powering non-power dams versus
That's
upgrades
just
to the existing? That's
existing,
all just
yep.
upgrades. Yeah. Wow.
All upgrades, yeah. So yeah, there's
awesome.
what we're able to do.
Sometimes people
generators
forget that
now.
with hydro, just the scale of it.
Go ahead.
Sorry, I think we had a our internet cut out for a second.
Okay. Okay. Yeah. So it's
Yeah,
just,
sorry
yeah,
for stepping on.
just for our existing stuff. So then the next item is powering non-power dams. And so we, like I said, we have over 400 dams, and in Reclamation's process is we do lease of power privilege, we call it LOPP, where we allow private entities to use reclamation assets like dams or conduits for electric power generation. It's a review process, so it's either Reclamation LOPP review or FERC, not both. But then it's under a reclamation review where an entity can come in and propose putting in a generation source at one of our existing facilities. So we review a lot of those actually on our throughout all these years. And so that's pretty exciting too. And we're trying to, back in the day when we put a lot of these power plants on, they were base loaded. So they just came up to peak efficiency, ran when they needed to, and then came offline, or would just run constant, more kind of like nuclear, base loaded. So now with so much diversity of our grid system and need for voltage stability and of our support, we are seeing that we are being requested to frequency follow sometimes, or come online, offline, and be more flexible. And when we're overhauling our units now, we're looking at, instead of base loading and designing our runner or our water wheel to be a peak efficiency at one point, we're trying to really optimize and make a really wide range, flexible operation from wide range of head ranges in our reservoirs, plus flexibility from very low output to maximum output, and have that flexibility for operations. And of course, increase efficiency when we replace our runners. So with a new hydraulic design. And this shift in how flexibility is in hydro, we're seeing more off-on operations. So before we might turn on a unit and run it for days. We might only have 50 start stops a year. Now we're being asked to increase start stops to almost daily or twice a day. And that puts a lot of wear and tear on our components. Our shafts have, it's now, instead of rehabilitating a unit after 50 years of service, rehabilitating like shafts or major components and putting them back into service for another 50 years. Now we're needing to look at, do we need to replace those components because they've exceeded their fatigue life? And so that's something that's really going to be changing in the future. And we really need to see what is the best model for hydro. Is it worth it to increase those start stops at the risk of replacing critical, expensive components? And I think what we said before, we can come on really quickly and ramp up really quickly and get those power demands when needed, when the wind stops blowing and the sun stops shining. And we're pretty quick to respond type of energy source, which is really exciting. I enjoy it.
Shanna, oh, sorry.
Good.
We had a question from the audience about specifically which systems are leading to that increase in capacity of 2.2 gigawatts that you referenced. Gigawatts, did I get that right?
So what facilities?
I think turbines or other systems like generators, like specifically which systems are you refurbishing or replacing?
So yeah, I'm all hydro in Beer Reclamation. And 96% of our generating units are Francis type runners, which means it's medium head range. And so when we're upgrading the generator. So we're putting more copper into the generator itself, better insulations into the same spot, so we can uprate that generator capacity. Then we also need to look at the turbine side, the runner side, the water wheel side, to make sure that that can output and meet that new generator capacity. A lot of times it can't. So replacing the runner itself with a higher increased capacity, Plus, we also look at higher efficiencies and plus wider operating ranges so that we have that flexibility. So the new hydraulic designs are incredible as far as versus what they were in the 40s or 50s designs. So pretty awesome that we asked for a ton of stuff from turbine manufacturers and they seem to be able to deliver that for us.
Do you see that as continuing to grow, or is it kind of, the in the 40s it was one thing, and say 2000 or like when are we, like I know with wind and solar there's massive decrease in costs and that, but do you see like there's potential to continue improving turbine design substantially? I guess that's a total what does your ball say?
Right. So yeah, back in the days, like I said, we were base loaded. So we had these very thin, basic design runners, really boring kind of shapes. And now we're asking for wide flexibilities, all this. We have very curvy, thick blades now that are optimized using computational fluid dynamics and model testing. So, but we're also, the runner itself, it's up to 96% efficiency. I mean, that's huge. And so the runners back in the 40s could have been 92%. So we haven't increased a whole lot, but it's kind of hard when you're getting up to 96% just on the runner itself to get to 97 to get, even a little bit higher efficiency. But what we're seeing now is that we're not looking for the highest peak efficiency at hydro necessarily. What we're looking at is a really good high efficiency over a wide operating range and be able to operate from 0% to 100% and cavitation free. A lot of times being asked to operate everywhere can cause cavitation damage on our units and a costly repairs. So we're instead of going for the highest peak efficiency runner that we can get nowadays, we're looking at more flexibility of operations with the still high efficiency over a wider range. But yeah, they could definitely improve slightly here or there, but it's pretty high efficiency already.
That's great.
So Sean, before I move us to the last question, we've gotten multiple questions from the audience about the role of water in hydropower. So one person is asking about the impact of drought. One person is asking about low reservoir levels. And so as we move to the next question about some of the considerations and competing interests that influence the role of hydropower, can you speak specifically to water in a changing climate?
Yeah, I mean, that's a challenge. And I think, like with it, everyone focuses on, okay, there's climate change, but I think just as important, and I think, Shanna, with all your work in the Pacific Northwest, like the natural variability is massive. And so, how much climate change is impacting that, that's on top of what already is a very dynamic system that is all over in terms of, how much water you might have in a given year. And so that, I mean, I'm really, obviously the West is in a position now that water is on the news and everyone is aware of kind of what's going on at Lake Powell and elsewhere. And there's real concern about how we're going to just provide the water. And we're, hovering at that threshold where we're not going to be able to generate and that. And so, yeah, I mean, as a general comment, I think just that recognizing the natural variability is a real challenge to hydropower, and because it is a dispatchable form of energy, yet at the same time it also is very dependent on the natural system to provide the fuel for that, and so that's in some ways it's a different form of variable generation. It just is less variable, right? There's more ability to store and save it for later. I think one piece that kind of go into how can we use our existing resources more effectively is like, how do we better operate with considering like forecasts of what is coming, and this kind of in the West in particular, like all the runoff that comes in a given year, or the majority of it comes in the form of snowmelt, and so you have this big spring runoff, early summer runoff, and so there's a lot of effort in, okay, well, what is going to be coming up, and how do I need to operate the reservoirs to position myself for that incoming that incoming wave. And so, there's a big push now towards FIRO, or forecast informed reservoir operations, and trying to better take advantage of that forecast information and the uncertainty, and when we're making a forecast in January on what's coming up versus in end of April, there's a very large difference in terms of what we can expect from that. And so I know that kind of dancing around a number of different pieces there. There's a lot of work right now. RTI just was, we're part of the Cooperative Institute for Research to Operations in Hydrology, which is a national effort to really move forecasting as a whole across the nation forward. And so we're excited about that. Just so there's potential to improve the forecasts themselves, as well as improve the use of those forecasts.
And then I'll open it up to the panel for any additional things, water related or otherwise, in terms of considerations and competing interests that may influence how hydropower is used.
Well, I just wanted to mention one thing that kind of complements what Shanna was talking about, and also addresses one of the questions in the Q&A. Right now, and this goes before, Sean mentioned the IRA, but there was also the bipartisan infrastructure law. And so there's the bill 243, which focuses on hydropower efficiency. And there's funding through the Department of Energy to increase hydropower efficiency. So if you're not aware of that, check that out. That one I don't know a heck of a lot about, but the one I do know a lot about is Bill the 247, Section 247, and there's roughly $560 million, and you'll see applications for grid reliability projects. We'll start taking them probably in the May timeframe on those. And so those, and on that one, it's not just grid reliability, but it's also dam safety, because there was a question about some of these assets being built 50 plus years ago, and how do we make sure that they stay reliable. DOE does have programs to address that. There's, as part of 247, there's dam safety, there's grid reliability, and there's also environmental aspects. And so there's funding for that for like owner operators, up to covering 30% of their project. I think it's capped at like $5 million a year. I don't quote me on all the details, but it would be something good for you to look into as far as efficiency, and then also keeping some of these older assets so that they're running at their best.
I'd like to flag a couple of questions from the audience that we haven't gotten to yet. So we've been talking a lot about riverine systems, and we do have a question from the audience. Could any of you speak to ocean waves and tide energy as a source of hydropower?
Do you have?
Yeah, I can.
Okay.
So, sure. The part of those, the challenges in those areas are just technological readiness levels, TRL levels, you'll hear people talk about. There just hasn't been a lot of research done to date, but we have done work up in Alaska. Oh gosh, I'm blanking on the name of it. It's a huge sound by Anchorage. Anyway, in that area, tidal is really steady there and looks very promising. And you'll see a report released by us in the not too distant future, where we looked at it from a grid perspective. We're tying in at Homer and then getting that energy up on the Alaska rail belt. So there'll be work there that you can kind of look into to see how that plays out. And the challenge there in tidal is super predictable, right? But ebb and flow every day. And it doesn't always match your patterns as far as your load patterns. And so it's spacing your turbine arrays out so that you get a nice, smooth power output that you can provide energy when you need it, and that you don't run into issues where all of a sudden you're dropping out because the tide happens to be in between going in and going out. On wave energy, that's a little further into the future. Still pretty good on predictability, not as good as tidal by any means. The challenge with wave is it's kind of spiky right now. And so economically that becomes tough, because if you build a unit that can get all the power into the substation, then that means you have to have pretty massive cables to get that in from your wave devices into the shore, the substation. And so we're trying to look at ways to address that. But that's really the biggest challenge right now in the wave space.
I mean, at this point, marine energy or hydropower from marine energy is a just drop in the bucket compared to other forms.
Yeah, it's
from what I
very,
understand.
very, very small. And another challenge, an obvious one, I should have mentioned it right up front, is it's only in a few places. For the US tidal, the Alaska region, Cook Inlet, it finally came to me. And then over up near Maine as well, but the other areas of the US, they're just not really, tidal's not a great source of energy. Wave is a little wider availability, but the challenge there is just technologically, we're still a few years out.
We also had a question about the shift in hydropower and the distribution of hydropower capacity from large installations to smaller installations. So the question is, can one of the panelists speak to the shift in distribution and capacity of new installations to smaller than 100 or 10 megawatt sizes, and the potential for even broader distributed hydro generation at the mini, micro, and pico capacities within the power grid?
So I guess, yeah, it started off that we started off building at the big locations, the big spots already. And the Corps of Engineers, their mission is navigable waters and flood mitigation. And Bureau of Reclamation's mission is bringing water to the West. So our missions are different. So that's why we have different spreads over where we operate and capabilities. But yeah, we really started really building at the best locations first and took advantage of that. And then as far as small hydro, for the Bureau, we don't really do a whole lot of smaller hydro. I mean, our smallest unit is 350 kilowatts, which is our smallest, and our largest is 805 megawatts. So we have a wide range, but that's now going to lease the power privileges at our existing facilities. And then as far as building new stuff, I think it comes down to all the regulatory stuff, environmental impacts, and cost, maybe, unless somebody else wants to speak to that.
In terms of micro hydro, I feel like I've heard most about that from our local customers, like water utilities, who are considering that. So maybe at a bit of a different scale than what we've been talking about here today.
And at least in our research, there's kind of renewed interest in the smaller, under 10 megawatt, especially in the powering of non-powered dam space, because that size seems to be kind of a natural fit for many of those installations. And so people are starting to look into that and explore it. So the other thing I'll just mention in passing, and I don't know, I haven't worked with them in a few years, but Natel Energy was looking at using small hydro actually for river restoration, which is a really cool idea on that. And so I don't know how that has progressed, but there was some talk about strategically locating impoundments to actually help recharge groundwater and things like that. And so that might be another area to check out.
Greg, I feel like your answer has led us into the topic, which was part of a question that we partially answered around environmental impacts and benefits. And really the question was that environmental groups may think negatively about hydropower in terms of its environmental impact. And so what environmental impacts should we be aware of? And then what benefits can it have that maybe we're not thinking about?
Yeah, I mean, I think the environmental impacts is a really interesting question with hydropower, just because yeah, there's very clear concerns about hydropower, and when you're changing the flow regime on a river system, what does that do to the biota and that in the river system? And the lower Snake, I know that there's a big push right now that there's a legitimate push to try to remove some of those massive dams. I don't know if Reclamation, but the federal has invested a lot into fish passage and that, and some of those lower snake dams, and yet there still is this big push, like, okay, we need to get rid of these. But that's challenging, because yes, that would help for the fish passage, but if you take those dams out, that is a massive source of renewable energy, and
we've looked at that, and just what it would set them back on meeting their RPS standards. I mean, it's not negligible by any means.
Yeah, so I mean, there's this juxtaposition of, you have the direct impacts of what this is doing to the flow regime, yet if you don't have that, does it set you back in terms of meeting the carbon emissions goals? And so it's maybe a little more complicated than kind of what we think about. But I think that's that whole thing with the lower snake, like, that we've thought about, and Greg, we were talking about this at one point, just the societal values and that of I think a big reason for the drop off in installation of dams, and that came to like a renewed or increased interest in environmental impacts and that, and so that really caused a shift in how many dams were constructed back in the 60s and that, and but then, like, thinking about legislative changes or things like, okay, if something went through to take out decide to remove the lower snake plants, like what sort of impact would that have, or the treatment of tribal rights to water, like if their first, the whole Western philosophy of water management is first in time, first in priority. Well, if the tribal rights are before anyone else, then what does that mean in terms of, and so I mean, like, as a society, if we shift towards that, then that could be a big change in things. I'm not saying that's good or bad, it just is another consideration as we're just thinking all through all these different pieces.
And just touching on that, I mean, one of the interesting things, Sean mentioned there was a move away from building dams, but for me, the really interesting thing is in the last 3 or 4 years, you've seen where environmental groups and even some of the river groups now are starting to understand that, if a dam is going to be there anyway, because you need it for other reasons, whether it's for agriculture, municipal water, whatever, the environmental groups are actually pushing for getting the most out of it in terms of hydropower, because they know that it helps them meet their overall low carbon goals. So it's been an interesting shift to watch happen. And in particular, if you're interested in learning more, Uncommon Dialogues at Stanford University, they've done a lot of work in that space.
And
So
then Amy,
Cam, oh, go ahead.
sorry, I was just going to say, Amy, you had mentioned just the equity with energy equity in that, and I think that's another interesting piece. I think in the U.S. that's less of a like, everyone essentially has access to energy, but like, you think about international development, and there are places like where that really isn't the case. And I'm not saying necessarily everywhere in the U.S. I know, Greg, you've been doing some work in some areas, but like in the Congo, that like 20% of the population has access to electricity, period. But the whole one of the discussions there is the Grand Inga dam and that whole group, and so, like, building that out, that gives access to energy for a very large region. And so just all these competing interests. There's the interests of, or the impacts on the environment, as well as the societal impacts, the potential for bringing people, helping lift people out of poverty, and all those sorts of questions that come into this.
And competing interests, the other thing, it really varies by part of country, because you'll get some areas where they actually love a new hydropower type development because of the recreation dollars and things that it brings them. Other area that countries saying, no way, you're not going to build anything here. And so it's just amazing, the split.
Chairman, if you wouldn't mind advancing us to the last slide, I'll go over some logistics, and then I want to give the panelists each a minute to think about. I think we'll have time for a closing remark. So if there's one thing that you didn't get to say or one thought you want to leave the audience with, take the next minute to think about it. And you can also pass if you don't have one. I believe we got through all of the questions that were submitted, but if you had a question that you didn't ask, or you want to follow up on your question, please feel free to contact each of our panelists separately, or you can reach us at climate@rti.org, and we'll make sure that your questions get fielded to the right person. We'll be sending out a recording of the webinar to all registrants in the coming days. And we just really appreciate your attention and interest in this topic. So who looks the most ready? Shanna, how about you?
I think we had a lot of great discussion here and very broad topics. We touched on a lot of different entities in this very short. It felt like it went really fast, but yeah, I just appreciate being brought in and to participate. And I've been in hydro for almost 20 years and I never leaving. I love it. And yeah, thank you.
Greg, how about you?
Sure. Yeah. First, want to do the same up front, say thank you for inviting me to participate in this. But one thing I wanted to follow up a little bit more on is probably not surprising coming from a systems guy. I mentioned that we're looking at storage and trying to make the best choices in terms of storage, and work done by one of my colleagues, I just want to mention it here, and I talked about it, was the impact of storage over its lifetime. And pumped storage hydropower comes in about half that in terms of carbon emissions to other forms of storage right now. I'm not saying that won't change, but I would love for people to think about things holistically. If our goal truly is carbon, think about carbon impact over the full, from cradle to grave on that type of tech, no matter what type of technology you're thinking about, for the grid.
That's a pretty good thing to end on. But Sean, do you want to follow up on that? I'll leave it at that. I don't have a lot else. I mean, I appreciate everyone coming and joining the discussion, and yeah, hope that it was informative.
Thank you all so much. Have a good rest of your day.
Thank you.